This video shows how to conduct hypothesis testing for the population mean mu. So the first step is to determine the level of significance alpha. The level of significance is the maximum allowable probability of making type 1 error, and usually is denoted using alpha. Second, we need to determine the type of hypothesis test based on the hypothesis statements. So if the hypothesis statement has the alternative hypothesis as mu is strictly less than k, then this is the left tail test. If the alternative statements has mu is strictly greater than k, then this is the right tail test. And lastly, if the alternative hypothesis statements is mu is different than k, then you have a two-tail test. So differences mean it can be less than or it can be greater than. So that's why you have two-tail test here. And keep in mind that the null hypothesis always includes the equal sign. Could be greater than or equals, less than or equals to a value. So you always have equal signs in the null hypothesis statement. And then the next step is you find the standardized test statistics. In this course, there will be two standardized test statistics. First test statistic is a z-test, and the standardized z-test statistics is calculated using this formula. You take the sample mean, subtract the mu, which is the population mean, divided by population standard deviations and divided by square root of the sample size. Again, z equals to the sample mean subtract the population mean. So you get the population mean from your hypothesis here. And then you divide by population standard deviation divided by square root of n. So you use z-test when sigma is known. So if you have information of the population standard deviations, you can use t-test if the population is normally distributed or the sample size is at least 30. Okay. And the second test is t-test. So the formula for t-test is very similar to the formula of z-test. So the only difference is instead of sigma, you have s here. And it makes sense because we use t-test when sigma is unknown. And also when the population is normally distributed or the sample size at least 30. And when sigma is unknown, you can use s to replace sigma to calculate the standardized test statistics. So there's two different types of test statistics. It could be z-test or t-test. So you use z-test when sigma is known and t-test when sigma is unknown. You can use one of these tests when the population is normally distributed or the sample size is at least 30. The next step is you're going to make decisions. In making decisions, you can use either p-values or critical values. So how can we use p-value to make decisions? We can find p-values using the z or the t standardized test statistics that we found in step 3. And depending on the types of the test, the p-values is calculated differently. For examples, the p-values for the left tail test is the probabilities to the left of these values of the test statistic. The area to the left of this test statistic. For the right tail test, the p-values is the probability of the area to the right of the test statistics. The area to the right of the test statistic z or t-test. And if you have two-tailed test, then the p-values will be 2 times the area to the left of this test statistics, or 2 times the area to the right of this test statistics. Depending on your scenario, the test statistics for two-tailed tests can be either on the left side or on the right side. So once you find the p-values, you can use this rule to make your decisions. If p-value is less than alpha, which is the level of significance, then you reject the null hypothesis. And if the p-value is greater than alpha, then you fail to reject the null hypothesis. Thesa says that if p is too low, then the null has to go. That implies if p-value too small, which is smaller than alpha, then we have to reject the null hypothesis. And then the second method to help make decisions is using rejection regions. So rejection regions are the regions that are determined using alpha, level of significance. For example, if you have a right-tailed test, then this area here under the black shaded area is the area representing the alpha. If alpha is 0.05, then this area here contains 0.05 probability. Similarly, if you have a left-tailed test, then this black shaded area here representing for the alpha, which is the level of significance. And if you have the two-tailed test, then this two little black shaded area here representing each representing half of the alpha. And using alpha, you can find the critical values. Okay, so critical value is a values that separating the non-rejection regions, which is this regions, and the rejection regions, which is this regions. So if you find test statistic z or t and the z or t values falls into the rejection regions, then you reject the null hypothesis. If z or t falls into this non-rejection regions, then you fail to reject the null hypothesis. And the last step is, once you make the decisions, you can interpret the decisions based on two factors. First factor is whether the claim is the null hypothesis or the claim is an alternative hypothesis. And the second factor is whether you reject the null hypothesis or you fail to reject the null hypothesis. For an example, if the claim is a null hypothesis and then you reject the null hypothesis, you can say that at alpha level, there is enough evidence to reject the claim. There is enough evidence to reject the claim. So, and if your claim is the alternative hypothesis, and you reject the claim, you reject the null hypothesis, then you can say that at alpha level, there is enough evidence to support the claim, because at this point you rejecting the null and the claim is in the alternative. That means you have enough evidence to support the claim. And if the claim is the null hypothesis and you fail to reject the null hypothesis, then you can say that at alpha level, there is not enough evidence to reject the claim. because you failed to reject the claim, which is the null hypothesis. Lastly, if the claim is a null hypothesis and you fail to reject the null, if you fail to reject the null, that means you're supporting the null, then you can say that at the alpha level, there's not enough evidence to support the claim because you're supporting the null and the claim is in the alternative. So that means you do not have enough evidence to support the claim. So this tables here will guide you on how to interpret your decisions based on whether the claim is a null hypothesis or the alternative hypothesis, also based on your decisions whether you reject the null hypothesis or fail to reject the null hypothesis. So let's do an example. So the first example is a random sample of 50 medical school applicants at the university has a mean raw score of 31 on the multiple choice portions of the medical college admission test. A student says that the mean raw score for the school's applicants is more than 30. Assume the population's standard deviation is 2.5 at alpha equals 0.01. Is there enough evidence to support the student's claim? So the first thing we want to do is we want to write down all the informations, right? So we know that the sample size is 50, n is 50, and we know that the mean raw score of 31 on the multiple choice portions. So that means the x bar, the mean score of the 50 applicants here, is 31. So x bar is 31. And the student says that the mean raw score of the school's applicants is more than 30. This is the claim that the student is trying to make. And assume the population standard deviation is 2.5, that means sigma is 2.5, and at alpha equals 0.01. We want to see whether there's enough evidence to support the student claim. So we write out all the informations that we know. And also now is the next step is we make the hypothesis statements. So the hypothesis statements is the claim is the mean raw score for the school's applicants is more than 30, strictly more than 30, so we know that mu is greater than 30, should be in the alternative hypothesis. And then we can figure out the null hypothesis, which is the complement of greater than 30, which is less than or equal to 30, right? And the sample size is 50, so it's greater than 30. So we know that the sampling distributions is normal. So we have a normal distributions here. And we know that the mean, the mean of the population is 30. And then we know that the sample mean, x bar, is 31, which is slightly greater than 30. So then at this point, since sigma is known, we know that we can use Z's test, and we can find the standardized test statistic Z, which is 2.83. Okay. And we know that this is also the right-hand test because of the alternative hypothesis statements. And then if we want to use rejection regions, we know that this should be the rejection regions, and we want to find the critical values. So the critical values of alpha equals to 0.01 for a right-hand test is 2.33. And we know that the critical value is 2.33 here, and the z-value is greater than critical values to the right, so the z-values is here. And you can see right away that this z-values here is in the rejection regions. Then we know that we should reject the null hypothesis based on the critical values and based on the z-values. But if we want to find the p-values, we can find the p-values as the area to the right of this z-values here, right? The area to the right of this z-values. And using the z distributions, we found that the p-values is 0.0023, which is significantly less than 0.01 as the value of alpha. So then we also know that we should reject the null hypothesis as the decisions. So the conclusions is, since we reject the null hypothesis and we know that the claim is the alternative hypothesis, that means we're supporting the claim. So we reject the null, that means we support the claim. And the conclusion is, at the level alpha equals 0.01, there is enough evidence to support the claim. The claim is the mean raw score for the school's applicants is more than 30 is a claim. Question number 2. An environmentalist estimates that the mean amount of waste recycled by adults in the U.S. is more than 1 pound per person. So this is the claim. The mean amount of waste recycled by adults in the U.S. is more than 1 pound per person. So then we can write the hypothesis statements. And we know that the claim is strictly more than 1 pound, so then mu greater than 1 is the alternative hypothesis. And we can determine the null hypothesis is mu less than or equals to 1. All right. So you want to test this claim. So you find that the mean waste recycled per person per day for a random sample of 13 adults in the U.S. is 1.51 pounds, and the standard deviations is 0.28 pounds. So keep in mind, this standard deviation is a standard deviation from the samples of 13 adults. All right. The question is, at the alpha level of 0.1, can you support the claim? Assume that the population is normally distributed. So we came up with the hypothesis statements. Now, here are more informations. First, the sample size is 13. Second, the sample mean from these samples is 1.51. Third, the standard deviations of the samples S equals 0.28 and alpha is 0.1. We know that the population is normally distributed. Thus, we know that this sampling distribution is normally distributed as well. So we have a bell-shaped curve for the mean. And the mean of this bell-shaped curve, it should be the claim, the population's mean from the claim. And this is the also another right-tail test based on the alternative hypothesis here. And we know that we need to use t-test because sigma is unknown. Because the population standard deviation is unknown, we have to use t. We can't use z. Also, the sample size is too small. So using t makes more sense. And if we use t, we find that the t values or the standardized test statistics is 6.56, which is big. So in using t-tests, it's better to find critical values, and it's easier to use rejection regions for t-test. So using alpha equals 0.1 and n equals 13, so then the degree of freedom should be 12. And if you use a T table, you can find that the critical values for one tail test of degree of freedom of 12 for alpha equal to 0.1 should be 1.356 is the critical values. So 1.356 here is the critical values, is a value that separate the rejection regions and non-rejection regions. And our test statistics is 6.56, which is further away to the right, which falls into the rejection regions. So we know that the decisions is reject the null hypothesis. So we reject the null hypothesis, and we know that the claim is an alternative hypothesis. That means we supporting the claim. So the conclusion is at the level of significance of 0.1, there is enough evidence to support the claim.